Hi there, my name is Rene Rubalcava. I'm a software engineer at Esri. Today we're going to be talking about building mapping apps with TypeScript. So first of all, what is Esri? Esri is a software company that's been around since about 1969, providing mapping solutions that entire time. Now they have desktop solutions, mobile solutions, web solutions, and all of that today is now provided via an online platform called ArcGIS. It's kind of an all-encompassing platform. And with this, you have desktop tools and web tools and, like I said, mobile devices and a number of different tooling that you can use. And what you would do is you could publish and share data on the platform, and you could decide who gets to view the data, how the data is used. Public agencies would use this, for example, to publish information related to parcels or maybe construction happening in the city so that the public can be aware of maybe street closures that are going to happen. That's pretty popular. And there's a lot of other information that goes into the ArcGIS Online itself. You also get to decide whether you want to share that data publicly or maybe you want to keep it private because there might be some sensitive data, so you only want to keep it private for your organization, which is something you can also do. We also provide a number of out-of-the-box applications that you can use. These are apps that you could use to explore the data as well as maybe collect data. Maybe you go out in the field and you want to collect survey information, you could do that. And we have a number of APIs, location-based services, things like directions, routing, geocoding, which is where you could provide a point, we'll give you back an address for it, or maybe give us an address and we'll give you back the coordinate for the address. And you can do this in batches of hundreds to thousands of them at a time. And we also have a number of developer tooling that you can use. And you could use this tooling to build your own custom solutions. So maybe you want to build a custom web app, and you could do that. Desktop applications, and again, native runtime applications on mobile devices. We have SDKs for just about anything you could think of. Now, because it's a web-based technology, most of our web-based apps are going to be based around our ArcGIS API for JavaScript, which has been around for quite a long time, through a few different iterations at this point. We are now on version 4 of the API. Now, version 4 of the API today is 100% TypeScript. I want to talk a little bit about that transition that we did from pure JavaScript to TypeScript. So we started the transition over to TypeScript from JavaScript a few years ago, starting with 4.0 beta 2. So before we even released version 4 of our API. And we started with TypeScript 1.6. And we just recently finished completely finishing the conversion at the latest version of our API 4.16. So it's been quite a few releases that it took us to do, but it's been totally worth it. So the way that we do it is that we take our TypeScript and we compile everything down to JavaScript files. And there's a few pluses for this and things that we've enjoyed doing with using TypeScript. One of those is the fact that we can do very large refactors efficiently. So you can imagine we have a large code base here. It's 420,000 lines of code, roughly about almost 2,500 modules in our API. So if we want to do any kind of refactoring and we had to do it with just pure JavaScript, it would be very inefficient for us to do. And I'm sure there are tools that you can do some pretty large refactors in a JavaScript app like that, a JavaScript project that big, but TypeScript just makes it completely seamless. I changed the name of a function in one module and it might propagate through about 36 modules for me pretty easily. I can change typings, change references to typings, and everything just kind of works. And I get any errors that might pop up because I changed some sort of type somewhere. Immediately I can get some feedback and be able to make any changes I need to do. Another huge plus for us is the fact that we have had to historically support Internet Explorer 11. So we can compile down to ES5 and still take advantage of a lot of the latest JavaScript features that are out there. And we can use various polyfills or let TSLib go ahead and inject what it needs to do when we build from TypeScript. So it's really just a huge benefit. We're really big fans of TypeScript, and we've had quite a joy using it. You can see here that we, like I said, we started 1.6, and over the years we upgrade to version TypeScript. When we have a release coming up, we'll upgrade to whatever the latest is. And when we do these upgrades, typically we'll get some errors that have to do with either the way TypeScript is expecting us to do something with our types. So we just need to go in and kind of adjust how maybe we're doing something with our typing, or it might actually point out some errors that might have popped up in our code, which no, they aren't necessarily errors, but just that we're not using types correctly somewhere, which is always really nice. We've even had a couple of cases where we had to wait for TypeScript to actually patch something that wasn't working 100%, which was really cool. We were at 3.3 for a long time. We had to do quite a bit of tweaking to make sure everything worked, but then once 3.8 came out, we were ready to go ahead and upgrade everything right away. So you can see that the con here is going to be a migration cost, right? With every release of TypeScript, we have to go and have it test our code base, and as well as our tests. I didn't mention that either. So we do have about 2,500 modules in the API, 420,000 lines of code. That doesn't include our unit tests. So we have about at least as many modules for unit test that we have in our API. So close to about 3,000 files to test, and an enormous amount of code for testing. We have a very large test suite that's also written in TypeScript as well that we've moved over to. So there's an awful lot of TypeScript that we work with on a regular basis. So there is a big migration cost if you're moving from purely JavaScript from something that big to TypeScript, which is why it's taken us quite a while to get there. But I'm very proud to say that we're there, 100% TypeScript, completely worth it. The pros definitely outweigh any cons that there might be, and we're 100% happy with that. Now, because we're such fans of TypeScript, we spent so much time refactoring, rewriting the API in TypeScript to make 100% TypeScript today. We do provide a TypeScript guide to users so they can use it, go ahead and get started with their own projects. It basically tells you how to set up npm to install the right packages, set up your TSConf, and get started with a very basic one-page project. That way you can move forward and you can scale it up for what you want to do. Now, our typings are pretty interesting. We actually generate our typings from our custom JSDoc template that we use. And we only provide the public APIs. So we have a lot of internal APIs that we might use to build the JavaScript API, but we don't want to expose all of them. We only want the public APIs exposed, which is why we use the documentation to generate the typings themselves. This ensures some consistency across the board, and there won't be many breaking changes for users if we decide to change something with an internal API or do something a little different. We have some custom scripts to generate those typings, and we also add snippets from our documentation directly into the typings themselves. Since the documentation is created from JSDoc, it was pretty simple. Well, not simple, but it was one build tool we can use to pull some of the documentation snippets and inject them right into typings, so that when you use a tool like VS Code, like you see here, if you hover over a property or something that comes from our API, you'll get a snippet of the IntelliSense for that, of what the typings are, as well as a snippet of the documentation and a link to the documentation for that particular property or class that you might be working with. So it looks something like this on our end when we actually are building the API. Here I've got some JSDoc for a property on a class called layer, and there's some documentation that goes with that layer, and then it's going to generate the typings for that, and we create an interface for those properties, and it's also going to inject a little bit of the documentation in there for us as well. You can see here it looks a lot. The JSDoc for the actual snippet that goes in documentation is also injected right into the typings themselves, which is what gives us that nice IntelliSense pop-up, which is really cool, that little tooltip that you see in VS Code. You can get the typings a couple of ways. If you're working on a pure JavaScript project, you can install the typings from the @types repo. That'll work just fine. It's a pretty large typings file because we have a very large library. We've had to actually minimize some of the documentation snippets that we use because the typings got pretty large for definitely typed in order for us to be able to publish that way. So we've gone ahead and minimized that a little bit more. And you also get the typings if you install the package. So npm install at arcgis/core/core. That'll give you the our API for JavaScript, and also give you the typings in there as well. So one thing I want to talk about with the typings and some things that happens with TypeScript is that we use a feature in the API called AutoCasting. Basically, it's a convenience for developers that will let you provide objects that look like the what would be instantiated as a class in the API. So for example, here I create a map, and I want to have a base map. Now you can pass it a string. We have some named base maps in our API. So if you tell us the name of that base map, we're going to go ahead and load it and then create a base map instance for you. So in this case, the setter is a different type from the getter. So you see on the slide here, the setter for base map is a string, but the getter is going to be an instance of a base map class, which is going to have its own properties and everything. It's not a string anymore, it's an object. And TypeScript doesn't allow typing your getters different from the setters. So it doesn't play all that well in some cases with TypeScript in when you're newing up objects. So if you new up a property, and if you new up a class and you pass in an object, there might be parts of the object TypeScript is going to complain about that are missing properties, because it's expecting the full-blown class to be sent to it. You can get around this by going ahead and newing up everything that needs to be, that's a class instance that is going to be part of the properties. So I can say base map is equal to new base map. That would solve some of the issues. TypeScript doesn't complain about this one in this case, but it does happen once in a while in the API, and that's kind of how you can get around it in that case. Our constructors are typed, so this is why I new up each instance of properties that need that in the API. So I want to talk a little bit about what makes up a map. So you're building a mapping application, and you want, or maybe you want to incorporate apps into, you want to incorporate maps into your current application. So maps are composed of what are called layers. So this little diagram here just has a number of layers. They're kind of sandwiched on top of each other, and it's kind of the concept you can think of when you're creating maps. You'll typically have a base map, which is drawn at the bottom of your map. Base maps typically don't change very often. This could be something like satellite imagery, or maybe it's going to be street data or parcels. So those don't change a whole lot over the lifetime. So those are typically served as tiles of images. So you would cook up, or you pre-cook a bunch of smaller tiles of satellite imagery, and then they get served very efficiently to the browser, and then we just kind of stitch everything together so you can view it on the map. You can also do this with vector data, so you can cook up vector tiles, which are going to have optimized vector geometries inside them, and then we just kind of, again, stitch those up from tiles into a very seamless map. So that's how the base maps work. Then we also have feature layers. Now these are going to be data sets that might change often, right? So maybe this is going to be something like utility data, where the like we'll say water, so flow of water lines can change over a period of a day. So that is information that can change. Earthquake data, any number of data sets that could change quite often are going to be published as feature layers. They can be very large data sets or small data sets, but the key is that they are interactive and they're dynamic. So you can actually do some really cool things with feature layers that we're going to see later on, which is a nice feature. We also have other layers that are part of the API. A lot of them are related. So we have raster tiles, which are related to base maps. You can have raster tiles on top of raster tiles and do some really cool effects with those. GeoJSON. So GeoJSON is a specification for serving geographic data, so points, lines, and polygons. So you can actually provide a URL to a GeoJSON file directly and create a layer from that. And then we have plain graphics you can add. So it's a graphics layer. We'll talk a bit about that later on. where you can just add graphics to your map. They're not really meant for being persistent. They don't get saved anywhere or anything. And then there's a few other layers in the map as well. But for our cases, we're only going to focus on a handful of layers to create an application. So basemaps. I want to talk a little bit about basemaps here. So we have typically two types of basemaps you would use. Raster, which is going to be, I think I mentioned before, like satellite imagery. There's an old saying, raster is faster, but vector is corrector. And this is true if you used to cook up base maps of, say, parcels. They look great at a certain scale, but when you zoom in, you start to see a little bit of fuzzing around the edges, a little bit of pixelation happening, depending how many tiles you cooked. The issue there is they can get very large, right? So if you imagine for a city, you cook up a bunch of tiles at one scale, it's going to be maybe, I don't know, let's just say theoretically 1 gigabyte for, it's probably just be a few megabytes for a city scale of tiles. But then you zoom in some more and you want to have it at maybe a street level. Okay, well now you need to cook way more tiles for the entire city to get that. So that few megabytes is now turned into a few hundred megabytes. And then you go in further even more to get a better level of detail for those tiles. And now it's turned into like a gigabyte of data. So you can see that these raster tiles can take up a lot of space very quickly. So another solution you can do is to use vector tiles. Vector tiles are pre-built tiles of vector geometry. The geometry is very efficiently stored in these tiles. It's typically served out as protocol buffers from the services that you get them from and then parsed directly on the client. And they're small and efficient. They, again, are very fast over the wire. They're quick to draw, and they're not as large. They're much, much smaller in space size. And I mean, that typically doesn't matter so much if you're hosting the data on something like the ArcGIS platform, but if you have it hosted internally, I mean, that's taking up disk space on your internal servers. So smaller file size is typically something you want to strive for if you can, right? The thing with vector tiles that sometimes people get confused with is that unlike feature layers, which we'll look at in a second, they don't really contain any information other than how to draw them. For example, you could have vector tiles of buildings, but you're not going to have information about, what is the name of that building? How tall is that building? That data is not really stored with vector tile data typically, right? So it just has information needed to draw and not much more, and that's what makes them so efficient to use. And you can see here you can actually create a base map composed of any layers you want. So you create a new instance of a map, give it a base map property that's going to have base layers, which can be a number of vector tiles. This will typically be, normally this would be tile layers, so it'd be like satellite imagery as the base layers, and then you have some reference layers on top of that. And this could be things like labels, maybe some kind of line work or boundaries to differentiate satellite imagery data. So you want to place some boundaries on top of satellite imagery so you can see what the difference is between states or counties or something. You can do it up like that, which is really nice. Now, layers are where things get a lot of fun, right? So we have a feature layer, and feature layers are kind of the one of the next to tile layers, like things for base maps. Feature layer is probably the second most popular type of layer that our developers are using in their applications. So you can use feature layers to draw vector data, things like we mentioned before, earthquakes, weather data, which is kind of a nice, any kind of buildings or detailed line work, lots of points, demographic information, all that can be drawn with feature layers. The key here is that you can use it to create some really powerful visualizations, which we'll also see a couple of samples of that. You can also query feature layers. So feature layers have all the data that drives the visualization. You can pull information out of there, get statistics for it, and they're performant, right? I mean, they draw really fast. They're drawn in WebGL. Actually, the entire API draws a map in WebGL, but the feature layers are really optimized to be very performant and display large data sets. And a derivative of feature layer is going to be something like GeoJSON layer, where you provide the URL to a GeoJSON file. We'll load that GeoJSON file, and it's now available on the client. You could still query the data on there. So you could take a GeoJSON file that only has basic information about earthquakes, such as the magnitude of the earthquake, the location of the earthquake, but now you can run statistics on it. You can say that where is the density of the number of earthquakes in a location. Let me get statistics on the maximum, the minimum, the average, standard deviation. And you can do all kinds of really cool client-side evaluations of the data, which is nice, and then drive visualizations with that as well. You can do the same thing with CSV files. So you provide a CSV file to a CSV layer, and you get the same effect. And all of this kind of works in tandem. And again, I mentioned before that we have graphics layers. Graphics layers are for drawing very basic data. They're not really meant to hold large data sets, but you can dump a whole lot of points or lines or polygons in there. But if you really want performance-based drawing in your app, you're going to be working with feature layers. And you can make client-side feature layers, which we'll take a look at in this workshop as well. Now, when you create a feature layer, you can provide either the URL to a feature service that's published somewhere online. So we'll load the URL up and load up the data based on the extent of the map that you're looking at, and everything just works. We also have this concept of working with items in online, and an item has a little bit more metadata associated with the layer, so it'll have information about who created the data, when was it created, copyright information, or any other kind of metadata to go with it. You give us the item ID, and we're going to go ahead and load the feature layer from the item and pull all of the stuff in that we want. What's cool with items is that if you do this in online, you can create the visualization based and save the way the layer looks as part of the item without impacting the source service, right? So the service is a reference to the item, and the visualization is part of that item. So now you can actually load the item, get the custom visualization in your map without having to worry about the source service at all. You don't have to worry about that. It just gets loaded for you. So maps and web maps, this concept kind of goes with what I just talked about with the portal items. You can create a map and add the resources yourself. So you can define the base map, you can define the layers you want to use, define the extents and the visualizations. This is where you can get down to some really fine-grained control of the mapping application that you're going to build. And you could use web maps. So web maps are it's a concept that we have in the platform where you can author a map in online, which is our online platform. We have a map viewer that you can use. You can add layers to it. You can create the visualization in this application. Then you save the web map, and now you can consume it in your own apps. And then once you consume it, you have access to the layers, any other information you define there. You can tweak it a bit, so you can take that custom visualization and maybe now tweak it just a little bit for your particular app when you consume the web map. You can also add more layers on top of it if you wanted to. So you're not confined to only using what is provided in the web map. You can continue to add data to it in your custom application, which is really cool. The demo applications I'm going to share with you today are available on GitHub. So you can find them at github.com/odo/tsconf-arcgis-workshop. You can go ahead and download the repo, run the applications yourselves, and get your feet wet using ArcGIS to build mapping applications with TypeScript. All right, let's go ahead and get started with a very basic mapping application using TypeScript. So the first thing I've done is I've gone ahead and imported some modules from the ArcGIS core package. I've got my feature layer, a tile layer, the vector tile layer, the map, and the map view. I'm calling it ArcGIS map here just so it's no confusion between the native JavaScript map, but you can just call it ArcGIS map. And you can see here as I hover over each of these, I'm going to go ahead and get the typings for here and just get a little bit of a, I'm not using it, so I got a little bit of a warning here. No big deal. Not a problem. I also have another file here for widgets. So the ArcGIS API for JavaScript comes with a series of widgets in it out of the box you can use to build your apps. And it comes with things like a legend widget, so you can get information about what is being displayed on the map, like what do the colors mean, kind of a thing. We have a layer list, which is just going to list out the different layers you have, and you can turn them on and off. There's a search widget, and like I said, there's a number of widgets in the API that come out of the box that you can use to build your applications. So let's start on this one here. So what I want to do is I want to be able to import something from the widgets module that's going to go ahead and create the widgets for me. So what I'm going to do is I'm going to export a function, and I'm just going to call it init widgets. And this function is going to take a view, and its job is to go ahead and add the widgets to the view. We'll see what that API looks like in a second here. So there is on the typings that we provide, we have a global namespace you can use. It's __ Esri. And on that namespace, we have things like the map view, as well as a scene view for 3D. Now, you may not want to type out the __ Esri everywhere. So what you can do is you can just do an import Esri is equal to __ Esri. And now I can go ahead and shorten these out. Over here. There, and that makes it a little bit easier to work with in some cases. So the first thing I'm going to do when I get my view, I'm going to go initialize a legend with it. So I'm going to say legend is equal to new legend. And as soon as I go the constructor over, it's going to tell me that I need to provide some legend properties. All right, so come over here, and I know I need, what you need to do is pass the view here. So as you see, as I can start typing, I get my IntelliSense here. The view is part of it. There's a view model. There's other properties that you could use when you create the legend. But in our case, we're just going to pass it the view. And what this is going to do is that whatever layers are part of the map that the view is displaying are going to get displayed inside the legend. I'm also going to create a layer list. It's going to be equal to a new layer list. And again, just pass that the view. And it is very basic. Simply, it's going to go ahead and display a small list of the layers that are in my map. And this particular map we're going to make right now is just going to have one layer, so it'll only be one layer displayed inside the list. So now the view has a UI attached to it. The view is actually what just draws the map on the screen, right? The layers and the map, they don't draw anything. They just have the information related to how to draw something. So the map knows what layers it contains, and each of those layers has information about how they should be drawn, and it gives those to the view, and the view takes care of all of the magic of drawing the maps on the screen for you. So that's kind of how this the API works. So the view has a UI section, and the UI area is kind of used for being able to add widgets. You can add your own custom HTML, maybe logos for your company, things like that you want to do. So you can see here I'm getting an error here on add. I did empty, expecting 1 to 2 arguments, but I got 0. Right, so I need to go ahead and pass something in here. So I'll pass the legend. Now, if I just pass the legend in here, it's going to go and display by default. I believe it starts at the top left of the screen, right? So it would end up over here. But I want it to go ahead and be at the bottom right here. So what I can do at that point is I can go ahead and give it a location I want it. So bottom left. And now I can go and do the same thing for the layer list. I'll just add that. And for the layer list, I'm actually going to want this at the top right. So you can see here that the values that it takes in the add is going to be a component, which is what I'm providing here, or a string. So I can add the ID to a DOM element, right? So if I have a DOM element on my page called info, just give it that ID and it'll go and add it to the views UI interface so that it's kind of lined up with the map and everything else. It's not just kind of sitting off somewhere. right? And then the position. So the position is going to be a string, which is I'm providing here. And then at this point, I'm going to return the view because I've gone ahead and added my UI to it. That's how the widget is going to work. All right, so in my main function, I'm going to have to import that over here. So the main function is going to import from, oops, can't type here, from widgets. We're going to bring in, it's called init widgets. Okay, so we did the widgets part. Now we actually need to do the actual layers in the map. All right, and I've got some information for the layers I'll bring in here for a second. So the first thing I want to do is I want to create a feature layer. Now remember, I said that the feature layers are the layers you would use to draw and your operational data that you want to be the focus of your application. In this case, normally, and probably like 90% of the times you want to do that. There might be cases where you want satellite imagery, kind of terrain data to be the focus of the map. But most of the time you kind of want some sort of operational data on top of that, right? So I'll create a new feature layer here. And instead of providing a URL, I'm going to give it a portal item. And a portal item is an item that we have part of our platform. Like I mentioned before, contains all the metadata for your layer. So I'll bring that portal item here, and I need an ID. So I've got that off screen over here. Just copy, paste that over here. And I also want to streamline this layer a bit. So this particular layer has quite a few fields inside of it. And the fields are basically, when you think of the layer, it's a database. It's a database that's going to contain geometries as well as a table of data. Could be like names, state names, information. In this case, it's like housing units. Are they vacant housing units or not? So depending on how the layer was created, if all the fields are visible, you could be downloading, say, 100 features, but there's 100 fields as part of the layer. So you're downloading an exponential amount of data. The more features that you're bringing into your application, so you can limit the number of features displayed, or sorry, you can limit the number of fields that are going to be brought in with each feature that you grab. So you do that with the outfields option. Now, one of the things that we do in the API automatically is that we look at the layer. If it has visualization, like the colors of the layer are based off of some field data, then we're only going to request the fields needed to draw the map. We're not going to request anything extra. So we already kind of optimize it at this point. But if you need some extra fields, maybe you want to do something like run statistics on a few fields and you want that available client side, then you want to bring those extra fields in with you when you're doing this. And in this case, I just want to kind of show how you can work with this outfields to kind of optimize your data, or make it work for your particular use case, which is what we would do here. Now I can also go to provide a title. Now since it's an item already, it has a title associated with it, but I want my own title. So I'm going to call this US Counties, and that's about it. I don't think I need to change anything else in here for that. So now I need to create my actual map. So I'm going to say my map is going to be equal to a new ArcGIS map. And for my map, I want to have I'm going to do a custom base map. And I kind of talked about this when we mentioned the base maps. I could just do a base map and say streets. And we'll see what this looks like in a second. And now if I create my view, right, so let's create a view. It's going to be equal to a new map view. And in my map view, I need to give it a container. So give me an element on the page in the browser that I'm going to try to draw this map. So it's going to grab a div. It's going to inject some code for the UI. So we have this whole way of structuring the map views where the zoom buttons go, attribution goes, widgets and everything like that can live. And then we put a canvas in there, and the canvas is what we use to draw the WebGL. That we draw on using WebGL all the data that we get, right? So I just need an element on the page that I can put that to, and I can just provide the ID for the element. So in this case, it's called a view div, and then I provide my map. And that is it. That's pretty much all I need to do at this point. So now if I save this and my build works correctly here, give it a second. It should let me refresh the page over here and get a map to show. Okay, let's refresh the page. And there we go. We've got a very basic map. I'm using the street data. This is raster tiles. So each of these is a tile that's been downloaded from the server. We stitch these tiles together. They're PNGs or JPEGs, and we're just going to stitch them together and then draw them inside of WebGL, right? It's nice, and this still looks really good. I mean, if you look at this, it looks great. The only time that you may notice anything at all is when you get really zoomed in. You start seeing some edges of buildings get fuzzy, but you're probably not going to be working at that scale. You can have something like this, and you'd be just fine. However, I want to go ahead and bring in my own custom, define my own custom base map with a couple different layers to do some things. So what I'm going to do is I'm going to go ahead and let's see here. So a base map has base layers, and these are the any reference layers, anything like topography, hill shades, which is what I'm going to use, and I'm going to go ahead and say a new tile layer. And this tile layer, this is basically how you would bring in raster data images layers. We have a separate imagery layer, but that's for like an image service that has a lot more functionality to it. This is just straight images with nothing too special about them. So I'll bring in a portal item and give it an ID, and I have an ID here. And then what I want to do is I want to also have a on top of this. So I've got the hill shade under it. Let me just make a note here. Hill shade. And then on top of that, I want some topographic data. So topo. All right, so this is going to be a new vector tile layer. So topographic data is kind of the contour lines kind of thing. Well, not contour lines, but it's topographic vector data that's going to be sitting on top of this hill shade data, right? So it's pretty cool. So again, it's a portal item. I have the item ID for this. I was going to put a string there. Not what I want. I want an ID. There we go. Okay, so now if I save this, and refresh the map, see we have whole new information. So now we've got this hill shade, which is like the mountains and the terrain data, and I have my topographic data on top of it, which is nice, right? So this is the all the labels and everything else, which is really cool. Man, that looks really nice. Look at that. That is a really nice looking map. I'm a big fan of that. You see, I was talking about contours, but actually we see on the hill shade, you can actually see different elevations going down the mountainsides, something like this. Where is this? I think it looks familiar. Oh yeah, okay, I know this area. It's really, really cool. This is nice. So okay, so I've got that now. What I have not done is added my layer. So I've created this whole layer and I haven't actually done anything with it. So let's go ahead and add that. You can do that on the map. When you initialize it, there's a property called layers, right? And I can just go ahead and say feature layer in here like that, and it'll go ahead and be initialized with my map. But I don't have to do that. I can do this after the fact and do something like map add, and then add my feature layer. That's another option. A number of different ways to do everything. As you also saw, there was an add many in here. So I can add an array of layers if I want to add a bunch of layers at once. So I can definitely do that. And then I have all these different properties to get access to things about the map, which we're not going to talk about just yet. So let me go ahead and save that. Wait for it to finish compiling. Just going to refresh the browser over here. There we go. So it's a US-wide data. So here is our feature layer that we brought in. And you can see the visualizations that I brought in here are done directly on the item itself. I didn't have to define what it looked like. It was already created for me. I'm just consuming it. So let's go ahead and use the init widgets function that we have over here to go ahead and take care of this for us, adding those different widgets. We want to have a legend over here and a layer list over here. I also want to go ahead and have the map zoom to the layer as soon as it loads. I want my map to be at a something like this, maybe. We go ahead and include Alaska. I want it to look close to this, somewhere around there, maybe like this or so. So okay, so how can I do something like that? So one way I can do that is I can go ahead and say that use view.when. So view.when is an asynchronous method that you can use that will fire when the map view has gone ahead and downloaded the data for the map. So it's gone ahead, it's fetched the feature service, it's fetched the base map information, and has drawn everything, right? Things are ready to, you're ready to start using the view for something. So if you need to access something on the view, things should be ready to go at that point. So let's go ahead and do pass it a function. And we're going to go ahead and say view.goto. So this is a helper method on the view that you can say, I can pass in an extent, so the extent of a particular area of the map if I know it. I could pass in some lat-long coordinates, and it'll go ahead and zoom to those coordinates, or it will center the map on those coordinates. I can also pass in a zoom level, which there are different levels between zooming in and out on the map that you can pass in, or a scale. If I know what scale I want it to zoom to, I can pass that in. Like I said, I can pass in geometries too. So the feature layer has an extent associated with it. Oops, what am I doing? Full extent. So I'm going to go ahead and pass that in here. I'm also going to want to go ahead and call that init widgets function and pass it to view. That's it. Go ahead and let that compile. And once it does, we'll go and refresh the map, see what we get. Oh, I know I did wrong here. Target cannot be no longer defined. Okay, so at this point, even though the view is done, the data for the layer is still being fetched. It's we're talking milliseconds of time happening here, but it is happening. So in order to work around that, let's pass this. Now, let's get rid of that there. Now, since we know, and I didn't mention this earlier, but when you do view.when, it's going to return the view in here. So this would also be instance of the view. I could pass that in here, and actually not typed in here. It's just going to be inferred as an any, but that would be the view. So what I can do is I can actually take this and pass it in here, and it'll go ahead and launch that init widgets. There's also a when method on the feature layer. So when the feature layer itself is done, I can go ahead. So this basically means the feature layer has been loaded. It's about ready to get drawn. Everything's happening. I can tell the view to go to the feature layer's full extent. Let's go and let that compile. Now this one should work. And then we'll talk about the widgets that we have in the map and everything, which is really, really cool. All right, there we go. So the layer loaded, it had the view zoom to the full extent of the layer, which includes the continental US as well as Alaska. And we have our legend over here. So the legend tells us that these are the US counties, and the colors on the map actually represent a range of values. So the percent of vacant housing units, meaning that the darker blue counties are going to have anything greater than 26% are going to be in the dark blue. Things in light blue are around 16, 15%, which would be something like over here. And then the ones ranging down to the color of yellow are going to have below 7%, like 10% and below. And here's below 7, roughly, of vacant housing units. All right, so that would be, and look at LA. LA County has a very low percentage of vacant housing units. I have not talked about the pop-ups yet. So this is a pop-up that was defined on the web map. We'll talk about pop-ups in a little bit in another project because they're really cool and they provide some detailed information about features on the map. It's like the main entry point. You immediately see a map, the first thing you want to do is click on it. So we'll talk about pop-ups for sure. So you see I have a legend that's already built for me that's going to get created based on the data on my map. And I also have this layer list that we talked about before. So that layer list let me go ahead and turn the features on and off. And you'll also notice as I turn the layer off, the legend goes ahead and displays no legend because the feature is not visible, so it's not going to have any information to display about the map at this point. It doesn't display anything about the base map. The base map is just a base map. It's there for reference. It doesn't really require having a legend. I mean, how would you put a legend for terrain? Right, so that's what this is going to do. So I turn it back on, and I have my layers. And you can see that we did that. It's not too difficult. We have a lot of help from TypeScript, giving us all the typing information, telling me when I was providing any when I didn't need to. One thing I do want to show real quick on this one is that we also have a other than a regular map view, which is how you would view this particular map that we're using. This is a 2D map. You can actually change this to a scene view. If I change all instances to a scene view, now we're going to go ahead and very quickly be able to change this 2D map into a 3D map, which is awesome. So let's check this one out. All right, it's going to refresh the browser. One little error there, and this just has to do with data that wasn't fetched right away. But here we go. Oh, yeah, look at that. That's nice. Now, I do want to point out, I point this out every time I show someone the 3D stuff, is that these stars you see here, I mean, that's real data. So this is the real position of the stars at this point in time that we're looking at the data. You could even define on the scene view what date and time of day you want the view to be reflected at, and these stars will actually change position. It's a small detail. It's pretty trippy. I don't know who would use it, but I think it's a great feature. It's pretty awesome. But we have the same exact map that we had in 2D drawn in 3D, which is really, really cool. And again, we have these pop-ups I mentioned before that we'll talk about in a little bit. Navigation in 3D is slightly different than 2D because you can navigate in the 3D environment. So we have different tools in here to let you do that. So I can just rotate the globe this way, and then maybe I want to pan around the globe, right? Zoom in. I mean, it's cool. So yeah, I just want to cover that real quick as a very simple application we got going here. These fields that I set for the outfields means that these pop-ups pop up really fast because the fields being used are already available in the features, right? Now, if they're not available in the features, because the only thing I need to draw here is the percent of vacant housing units. So we would only have, I believe, probably these two fields would be included with the features when the layer is drawn, right? So since we don't have the name, we don't have the state name, right? So this Coconino County, Arizona, since we don't have that data in the feature, when I click on a pop-up here, you would get a little spinner while it goes out to the service and it queries for that particular feature to get the fields needed to display in the pop-up. But because I didn't do that, because I added these fields to the out fields of my layer, I knew I needed them, then the pop-up is going to go ahead and be really fast, right? And that's just to make it a little bit more responsive on the browser. If not, like I said, you just wait a quarter of a second while it goes and gets that information for you. All right, let's try an app that's got a little bit more bite to it, right? We're going to do a little bit more here. We're bringing in the GeoJSON layer. We're going to go ahead and load a GeoJSON directly into our application. We're going to use the time slider widget. So this is a widget that's pretty interesting. Basically, when you publish a feature service, it could have some sort of time information associated with it, right? You can use that time information to basically slice the data up. So you can look at what this data is presenting. Say it's got information for like months, right? You can look at the data for the month of January, month of February, month of March, and kind of narrow it down. It can even play the data over. So if you've got, for example, earthquakes, and you want to see the earthquakes occur over a sped up time frame, you could watch an entire month's worth of earthquakes in just a few seconds to see how they occurred, which is an interesting visualization itself. Now, because we're bringing in a GeoJSON layer, it doesn't have a visualization predefined, so we're going to do that as well. You can do everything with the GeoJSON layer you can do with the feature layer. It's just because of GeoJSON layer, you have to define a few things yourself. So we're going to define a pop-up template, the fields that are part of the GeoJSON layer so that it can provide some more hints to our data. That way the API can do a little bit more with it. And we're going to query the GeoJSON layer and do some cool things with it. Let's go and get started here. So I've already got my GeoJSON URL. I have my alias typing here for my import Esri, and I have a little immediately invoked function here that I'm going to run. It's going to be a rapid and async function, so I can do async awaits directly inside of here. Okay, so first thing I want to do is I want to create my GeoJSON layer. So it's going to be to a new GeoJSON layer. And I've already got my URL defined at the top here. I'll say URL going to be equal to the GeoJSON URL. Now, because this is GeoJSON data, there's not really any copyright information associated with it. You should provide copyright info with your applications if it's coming from some source and you know where it's coming from. In my case, I know it's coming from USGS, so I just put USGS earthquakes, and the title is pretty much going to be the same thing. USGS, if I can spell, earthquakes. So now what we want to do is we want to go ahead and define the time information for this layer ourselves, right? Because again, it's just a plain object that's not, it's just got some lat longs associated with it, but it does have a date field inside of it for when these earthquakes occurred, and actually at the time field, so it's a timestamp when the earthquakes occurred. So we have this option for a time info that we can put in here. Now the start field is going to be the time field, and I know it's time field because I looked at the GeoJSON beforehand, so I know that it's already got these fields in there. And the interval, we're going to set that for 1 day. Right, let's go ahead and do, that's an object, and it's going to be unit, and that's going to be in days. You can see here the typings also provide a little bit of help for us here. So it's typed out to specific values. So I have minutes, months, seconds, milliseconds, hours, decades, and centuries. I mean, if you needed to, right? Which is awesome. That is so cool. And then the values, this is the interval value that we're going to be doing. We're doing 1 day. I could do 2 days or 3 days, but we'll stick with 1 day intervals, which is always a good, well, for this data set, it's a pretty good choice. So okay, so we got that done. So that's the time info. Next thing we want to do is define how we're going to visualize these earthquakes, which can get pretty interesting. So I'm going to define a renderer. That's the property that you want to call it. It's going to be an object. Now there are different types of renderers in the API. So if we come over here, we have a full visualization guide in our SDK that you can look at to figure out how these different renderers and everything work. Based on the data in which you want to try and show, that's a different type of render you might want to use, like location only, maybe some data-driven visualization, which is what we're going to do. So it's a thematic map, and it could be based off a field. Like I said, most of the time you would define these online because we have tools already built that can pick out the colors based on the base map you use and do some really cool things. But we're going to go ahead and do it manually. So we have manually defined renders. There's a full-on discussion in the guide about how this works. We have a concept called smart mapping, which are smart mapping APIs, where you can provide your layer, you provide the base map you're going to use, a few other properties, and we're going to go ahead and, based off sampling the data, figure out the best visualization for your layer based on the base map that you're using and the different color combinations and stuff, which is almost like having a cartographer by your side to help you build these cool looking maps, right? Because a lot of developers may not be cartographers or have that cartographic background. I have a slight cartographic background. I've made maps for almost 20 years now, but no, I'm not going to pretend that I can make really cool looking maps. If I do happen to make something cool looking, it's because I use tools like these. All right, so I'm not going to get into details on here, but we're going to use, in our case here, we're going to use a simple renderer. Now, if this is part of the AutoCasting that I talked about before, the fact that I can provide an object that looks like a class in the API, and we'll automatically cast it to that class under the hood for you. This is going to be a simple renderer. And in the API, there actually is, if I come over here, in the API reference, and search for simple renderer, we have a simple renderer class in the API already. So I could import this, I could new it up if I wanted to, or I could just provide an object and give it a type that's going to match what we say here. Right? And that's going to let us do this AutoCasting. And here, something like this, where I can just type it to a simple renderer. It's going to get AutoCast for me and everything works. Again, the symbols, which is how the individual features are going to get visualized, can also be AutoCast by using this type property. It's very, very useful, very developer friendly, and it just makes things a little easier for you instead of having to new up all these classes everywhere. Okay, so let's do the type renderer. Now I want this rendering to be based off one specific field. I want to base it off of the magnitude of my the magnitude of the GeoJSON layer. So there is a field in this earthquake data for that magnitude, and it's called mag. So field mag. Now you can already notice I'm getting some errors from TypeScript here, and it's telling me that this type property is not assignable to the render properties type, which is the typing for the renderer. It's got GeoJSON layer properties, which is a type of Esri.renderer properties. And the error coming here is saying that it doesn't match up. And that's because, I mentioned before, TypeScript doesn't allow typing the getters different from the setters, which is what we're actually doing with our AutoCasting, which can be a little, kind of a pain every now and then in TypeScript. But this is one of those cases where you just set everything on fire and type it as any, and the error goes away. So I got my field here. Now the symbol. This is what the individual symbols are going to look like. Now, by defining a single symbol, everything will look like this symbol when it's displayed on the map. And we'll talk about how you can tweak it a bit to make it a bit more interesting right now. So the symbol is going to be a simple marker. And again, I would go into way more detail on the visualization guides if we had more time. This is that would be a way more in-depth kind of a where am I? Developer tooling. That would be a much more in-depth discussion on going into how this data visualization, everything works. We have entire sessions in our on the Esri YouTube channel on how to do that. So if you want to look that up or look up the guides, please feel free to. So the color I'm going to use is going to be orange. And I don't want to outline. I'm not a big fan of outlines on my symbols a lot of times. I think they, depending on the map, gets kind of busy. I think the outlines kind of overshadow the actual symbols every now and then. So we have this concept in the API of, we call them visual variables. And these visual variables are ways that you can modify this symbol based on field values. So you can adjust the size of the symbols. So if a field falls within a certain range of values, the sizes will be smaller or bigger. And you can also assign change the color. So if the color, if a field value falls within a certain range on a feature, we can go ahead and change the color for that. And those look like this. Now I'm going to do a little bit of copy paste magic here. So I define a visual variables array, and that array is going to have objects. And these objects are going to be a size visual variable, which is going to have the field name for the magnitude, and they have these stops, right? So anything that's a value of 1 is going to be a size 5 pixels, value 2, size 15, and a value of 3, size 35. Now, if the value is, say, 1.5, then the API is going to go ahead and make it something like maybe 10, right? Because 1.5 is between 1 and 2, 10 pixels is between 5 pixels and 15 pixels. So it will kind of create this range for you based on the data and dole it all out for you, right? The same goes for color. So we're going to go ahead and have change the color for the visual variables based on the depth field that's in the GeoJSON data. And we have these stops. So if the depth is 2.5, it's going to be this particular color, which I can't remember what it is right now. And we're going to give it a label. And this label is going to be assigned to our legend. That's where you're going to see it. And at 3.5, we have this color. And at 4, we have this color. So we're actually going to create a color ramp under the hood for you. And then all the values that fall within those ranges are going to fall somewhere in the color ramp. And that's how they'll be displayed on the actual map, which is really, really cool. So now the next thing we need to do, so we did that. I showed you a pop-up earlier. We want to define a pop-up template for our layer. So by defining a pop-up template, we basically want to show some information when you click on the map related to the features themselves. So initially what you want is you want a title. And that title can be based off of a field that's already in the data. The way that you do that is that we have this little annotations you can do. So if I put brackets and the field name, like that, it's going to go ahead and display that value for me inside the pop-up. So I have a title for the pop-up, and then there's content for the pop-up. Now I can get into a lot of detail about how you can do different types of content in here. You can have a promise. It'll take a promise, so you can return some sort of asynchronous function that's going to pull information related on the feature you clicked on that's maybe coming from a third-party API. It's going to create some charts and it's going to throw in the pop-up for you, or it might pull images from somewhere or do something. There's a ton you can do with pop-ups. Like I said, that could be an entire workshop on its own. But for now, we're going to keep it a little simple and just actually define some fields that we want to show in the pop-up. So those fields, I'm going to have an array, and this is going to be my field information. So the type is fields for this object. And it's going to be have some information to it. So field infos. And this field infos is going to have some other information. There's also media. I think there's another one. I can't remember what it is, but I know we also have a media one in here as well. So basically what I want to do here is I have another object. This is actually going to be an instance of, and I'll come over here. It's kind of handy to have this SDK over here. Yeah, here we go. it's going to be an instance of this field class that we have in the API. We basically have to define the name, the alias, and then the type. We have different types of fields: strings, doubles. The OID is a unique ID that what you have in there. If you don't provide an OID for like the GeoJSON layer, we're just going to go ahead and create one for you. We use those unique IDs to do some fast querying of the data. It's like having an index for your data in the API. So I need a field name. I have a place, which is the location for it. So the label will be location. Do I want it visible? True. Okay, so let's copy this. All right, the next one's going to be the mag field, which you've seen a couple times already. That's shorthand for magnitude. I know that. So it's like slightly off. What's going on here? Normally I wouldn't notice, but VS Code makes it quite apparent that something's wrong. Okay, so let's copy that. Normally I work in Vim, and it's easy for me to do really super fast to do these kind of copy paste operations. But yeah, VS Code, I don't really like Vim mode in VS Code. It drives me nuts sometimes. So I have my depth field. We talked about depth already. We're using that for the visual variables. So we're going to render based off that field. So might as well show it in the pop-up as well. Okay, so that's our pop-up template with the title and the content defined. That is pretty straightforward. Make sure that... Okay. So that is my layer. I really don't like doing that. Let's go ahead and do that for now. Really kind of busy there. Okay, so now let's go ahead and create the map. So the map is going to be a new ArcGIS map. It's not a web map, so it's just a plain old map. I'm going to use one of the named basemaps that we already have as part of the API, which is a dark gray vector basemap. So it's going to be streets and buildings, but just in a very dark gray color. It's very useful for showing more colorful features on top of. We have that orange, and the orange in that dark gray background is going to work out pretty well. So I have my base map defined, then layers, and my layer is going to be my layer. So that's my GeoJSON data. Now I need my views, so I'm going to go ahead and say that my view is equal to a new map view. I'm going to provide a container. So the container is going to be the view div element. That's the ID for the div on the page I'm going to be putting everything in. Give it my map. I'm going to zoom in to a level of 13 here. And the center is actually going to be right around where these earthquakes are. So the interesting thing with this data set, and I've got this written down right here. That's why I did not have this coordinates memorized. The interesting thing with this particular data set is that there was an instance last year where we had a very large quantity of earthquakes occur within a very short period of time in the same area. So it made for a very interesting use case to create these maps and actually display this data in this way using that time slider to view it, to view the data over a certain period of time, which is what we're doing. So at this point, we can actually look and see what it's going to look like. So if I come over here, wait for this to build, I can refresh the browser. I don't think it'll error out on any because I'm not using stuff here. I don't have any linting going on here, so at least not myself. I'm not sure if VS Code's doing some linting for me, but I have not enabled ESLint or anything to prevent me from building if I've got unused things going on here. And TypeScript just remove that stuff anyway, right? Because TypeScript is awesome. Okay. So there we go. There's a map. This is all the data, just kind of thrown in your face. It's you can see it's a little bit busy because there's quite a few earthquakes that happened here. And you can see the different visualizations we have here, right? So the base color that we did was that orange color, but we have our size visual variables, which we defined up here. So let me close this, close that, expand this one here. So if I were to remove, let's go ahead and remove the visual variables here. Oops, that's not going to work. No, sorry, my bad. So that goes there. There we go. So let's comment out those visual variables that we added and just give you an idea what this looks like without the different visual variables, right? So no size difference, no color difference at all, just the data as is with orange dots, right? So that's the default there. So if we turn on visual variables again, I think you get the idea that this is a really cool way that you can, no, that's fine in some cases, but it doesn't really tell me anything. I can't really tell what's happening here. This could, you may tell me these are earthquakes, but okay, that's fine. I mean, how large were the earthquakes? I really can't tell from there. But when you do something like this, even though I don't have a legend on here to tell me exactly what's happening, if you just told me these were earthquakes, I'd have a pretty good guess. I would think, oh, okay, the larger magnitude earthquakes are the bigger circles, of course. That just makes sense to me. I may not know what the colors are exactly. I wouldn't quite offhand guess they were depth, but I knew they meant something. And I knew that maybe darker meant something, right? So yeah, I think that's just makes for a very strong case of doing nice visualizations. And we try and provide, being a mapping library, we try and provide the best tooling for that we can. So, okay, now let's go ahead and add this time slider to our map. So we're going to make a time slider. Const time slider is equal to new time slider. And again, we have this container property. I already have an element with an ID of time slider. Very creative. Now, time sliders have what's called a play rate, right? And how fast they're going to play. No, it's the rate of play. It's play rate, right? So got that here. If I hover over this, the time in milliseconds between animation steps, right? So we want to do, say, 50 milliseconds between steps when we play. So dum, 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 dum. Very creative, right? Do you like those sound effects? Me too. Okay, so now those are the steps. So what are the steps going to be, or the stops going to be? Yeah. So my stops are going to have an interval. We kind of define this in the time and similar information in the time info that we define for the GeoJSON layer, right? So we have an interval that we need to define. It's going to have a unit, and we're going to define a unit of hours, and it's going to be 1 hour. The value of 1. This is another one of those parts where TypeScript complains because it's missing some properties because we're doing this whole AutoCasting. I need to do I'm probably going to get scolded by someone on the TypeScript team if they watch this about doing this as any here. But you guys would, yeah, give us a. If you can figure out how to make it work, it'd be nice if we could type together as different setters. I'm just saying, guys. Yeah, I'm not trying to push it here. Okay, so we got that. Now I can add this to my view UI. We saw how we had done this before with the previous demo that we did. And the way that I've set up this time slider, if I did the CSS correctly, it should just kind of show up exactly where I want it to based on the CSS. So I don't want it to be in a corner or anything like that. So I'm going to just say manual is the method I want to add this to the map. And by saying UI.add this and then manual, it's just going to add it without putting it in a corner or anything specific, so you can provide your own CSS to position this on the page. If I did it right, there we go. Yeah, so there's our time slider down there. And we've still got to set some stuff up. So it's not quite ready for us to use yet. So what I want to do now is I need to get the layer view from the GeoJSON layer. And we have talked about the map and the view and how the map contains information about the layers. It doesn't really draw anything. It's the view is in charge of drawing. Well, for every layer that's in the map, it's going to create these layer views, and each individual layer view is in charge of rendering that layer. And then the map view kind of manages everything, right? Kind of is the distributor of everything and tells everything how to hook together and stuff. So I need to get a layer view, and the way you do that is going to be by asking the view when the layer view is ready. So when layer view, and then pass it the layer. And this is going to go ahead and give me my layer view. And it's a type of GeoJSON layer view. So it even knows that if I pass it a GeoJSON layer, I should expect to get back a GeoJSON layer view, which is very, very handy. So now I need to create a start date. So start is going to be equal to, it is 2019, April 25th. So that's the start date that I want to use. No, 25th? Yeah, that's right. And the time slider extent, full time extent. So this is the, I'll explain it much better, but it's basically the start time to end time that the time slider is going to be concerning itself with. It's going to be equal to, again, it's another object here, and it's going to be equal to the start time, and the end is actually going to be equal to the layer that we defined the time information for. So remember, we defined that time info on this GeoJSON layer. It has a full time extent, and now it has end time. And it's pretty interesting because if we look over here, we defined the time info. We didn't define that full time extent. But this got, when the GeoJSON layer was hydrated, it AutoCast this time info object that we provided. Oops. It AutoCast the time info object that we provided into a full-blown class of time info that also has that full time extent already on it. So we can go ahead and provide the end time to our time sliders time extent, which is really, really, again, that's one of those very handy things that we can do. Now again, we have to do the very first as any here, unfortunately. So now I need another end time here. So I need end is going to be equal to a new, so we're going to make it equal to the start time. All right, so it's a new date I want to do. And basically what I want to do is I want to set that date. So we're going to be showing the earthquakes with 1 day interval when the app is loaded. And we'll be showing those earthquakes for, that happen between that 1 day. And then the end of the current time extent for the time slider is going to be showing those earthquakes with a 1 day interval. So what we want to do is we want to set the date to the end date, but we want it to be +1. All right, so for the 1 day interval that we're going to do. And then, so the time slider can show those dates. We're going to say that the time slider values are going to be equal to start and end. And that's going to be the two small, what you call them, thumbs, I think, that show up on the slider here. And we can change the size of those and everything else if we wanted to. So if I save this, won't be quite watchable yet. Almost. There's still quite a bit more going on here. All right, so it's going to run. There we go. So see, this little thumbs are 1 day intervals now. And if I play this, it's going to go and play over 1 day. Now, even though the time slider is going over this data set in 1 day, it's not updating the layer yet. We haven't told it, as you change the value on the slider, as we go from 1 day to the next, these intervals, we need to tell it to do something to our actual data on the map. So we're going to do that, and we're also going to display some statistics for that data over here in the corner. So what we want to do is that As this changes, right? So as we change the time here, we have the 1 day interval happening. We're going from May 26th over here to June 2nd, and we might have, pause this here. This might be, it's going to be the 5:30 to 5:31, 5:31 to 6:1. As this time extent value over here is changing for this thumbs, we want to show those, filter the data out over here. So this changes, and we want that to update something over here. That's what's going to happen. We can make this longer and then move it some more. So we have this little date range happening here. So part of what our API provides you is the ability, this is part of what we have the accessor, is to watch for property changes. So instead of listening for events for everything, which we still have events in our API, but we try to make it so it's easier for you to not rely on events that we provide. If you care about certain property changing on some instance, then you can just watch for that property to change. So we're going to watch for the time extent property to change. That's what happens when it this moves along the slider. And as that time extent changes, we want to do something. So I'm actually going to be doing some work inside this function. So I'm going to make it another async function in here. And I'm going to go ahead and grab, do a little copy pasting here because there's quite a bit of code happening here, but I will explain it every step of the way. So on the layer, we actually want to provide a, change this to single quote. We want to provide a definition expression to the layer. And the definition expression is basically like a where clause you would do with SQL. And with that definition expression, you could do things like say that you only want to show values where the field is greater than 1, or only show data that matches this query, kind of thing, right? Those are the kind of things you can do with this definition expression. It's just a way that you can filter data out that it's going to try to fetch from the server, for example. So I'm going to provide that definition expression to my layer. And then I'm going to do something kind of cool here, where because the layer view is what's responsible for drawing data on the map, we already have all this data in the client. We don't need to go back to the service or that GeoJSON URL and pull any more data in. It's all here in the browser. So we can do some pretty cool things with that now. So we can get the layer view, and we can apply an effect. And we call this a feature effect. And a feature effect is going to allow me to go ahead and provide a filter. And this filter can have geometry. So the geometry is going to be equal to the extent of our view, so the view extent. And you can have a where clause in here, but you can also provide a time extent, which we have because the time slider time extent has been changing. That's what fired this whole function off. Remember that the time extent changes and we start running this function here. Now again, AutoCasting need to, well, we'll take care of that in a second. We need to do it over here as any. Now, that is going to filter the data. Now, you can also have, so that's the filter part. The effect comes in is that you can have an included effect. And I could say, for example, I want all of these features to have an opacity of 50% or something, right? So I can type opacity 50%. And that just means that everything that matches the filter is going to have this effect applied to it. And these are these CSS filter effects that you can find for the CSS documentation online for the browsers. They have these different effects you can apply using CSS. You can do the same thing with the API. Not all of them, most of them are in here, but you can do them a couple different ways. So you can do it things that match the filter or things that don't match the filter. And that's going to be under the excluded effect, which is really cool. So we've got that working for us. So, okay, let's go and save this and let's run it. And then we're going to this will actually do something pretty cool. Once we do that, we're going to get into some pretty nutty stuff you can do with these layer views and the layer themselves. Okay, so now it should be ready to go. Now we're going to play it. I did this right. This should all work. Oh, there we go. So it started from the first day. Pause it here just real quick, give you an idea what's happening. So this is all the data starting at the start date, 5/25, ending 5/30. So all the earthquakes happen between those 5 days. But we only care about earthquakes that happened between 5/29 and 5/30. So those are the ones that do not have this grayscale or opacity effect applied to them. The ones that are within the 1 day are the ones that don't have those effects. So they're brighter, right? So that is very, very cool. So if I keep playing, you can see it all play out. More data shows up, but more data also becomes opaque, right? It has more opacity applied to it. So these features are all popping in. They're all popping in. That's very cool. So on this particular day, there were not relatively a large amount of earthquakes, but a whole lot of earthquakes have happened up to that point. If we come down to here, we had quite a few earthquakes of a decent size. We had one really big one here. Well, big. If we the pop-up, we haven't even clicked on our pop-ups yet. We defined the pop-ups for the GeoJSON layers. If I click on that pop-up, there's the data for my pop-up. That's the title. That's part of the GeoJSON data. The location, the magnitude, and the depth. Right, so magnitude 2.6. Looks like that was the biggest one on that particular day. If we keep playing. Oh, no, this one. Here's a good one. The magnitude 2.8 at depth of 2.8. So that one is pretty decent. And here we go. So there was a lot of little earthquakes happening on this particular day. Right, so you can see all tiny little earthquakes happening here. Looks like this was like a magnitude of 1.4, but a depth of 1.8. So it was a small earthquake, but it was pretty deep. So I'm sure, I don't know much about earthquakes. So I'm sure it means something. I don't know. We'll find out, right? Yeah, so that's really cool. Now, visually, I can see that a lot of earthquakes happened on that particular day, but I can't sit here and count the number of earthquakes that don't have an opacity applied to them. It's just, I can't do that. Maybe you can. So what we can do is we can actually run statistics on this data on the client, because like I mentioned before, the data is already in the browser memory. We have it inside of a storage that we use in the API that we can query and do cool things with, even do statistics. So that's what I'm going to do. So what I want to do is, normally when you do these queries, you are going to query the layer, like a feature layer, and you can query the service itself using layer.queryFeatures. We have over here the documentation real quick. Look at feature layer, and we look at the methods that are available on the feature layer. We have all these query functions down here. Here we go. Query attachments, query the extent, query feature count, query features, object IDs, and so on and so forth. So it's a very useful way to be able to pull data out of a feature service. And you can do that against this GeoJSON layer. So what you want to do is you want to take the filter, right? So we're going to take the filtered results, create a query for those. And this is going to have the geometry as part of the query already, the time extent as part of the query already, any other kind of things we might have applied on the filter are going to be part of this query built for us. So we don't have to put that information in there again. It's just kind of populated for us, kind of clones that information for us. And now what we want to do is we want to create some queries here. So a second here. Oh, I forgot to add my legend. My bad. It's okay, we'll do that in a second. First, I want to do is define all of these queries. So there's a lot. So let me get these here. So we have, like I said, there's a lot. So I'm not going to go over all of them, but I do want, we try to name them in a way that you could figure out what they are. So for example, you define a statistics as having what field you want to run that statistic on. I want to run it on the depth field. What is the name you want it to come back as? I want it to come back as average depth, so that's going to be the field name that returns. And what type of statistic am I going to run? I'm going to run an average. Same goes for the max magnitude. I'm going to run a max on that, an average on that. The same, I want a min, I want the count, and I'm going to have all these different fields available for the max magnitude, average magnitude, minimum magnitude, and average depth. So I'm actually going to run some statistical queries on my data to get that information back. So I'll come down here. We have this on the query has this property called out statistics. I'm going to place all that statistic information in here. This, if you do SQL, this probably look somewhat familiar to you in the way that you do kind of queries against SQL databases to get kind of the statistic information back. It'll take care of all of that for you there. Okay, so now what I want to do is I want to go ahead and run some queries here. But one thing I forgot to do was add my legend. Okay, let's take care of that right now. Give me a second here. Actually, we'll have the legend after the fact. We don't need to do it right now. Let's finish up this query stuff that we're doing here. Okay, so what I want to do is I want to go ahead and run a this stats query against my layer. Now, I could run this against the layer view, and that's normally what I would do if this was a feature layer. I'd run against a feature layer view. But since it's a GeoJSON layer, we've already downloaded the GeoJSON data. It's just as fast to query the layer in that case than it is query the layer view. So what I'm going to do is I'm going to get a result. That result is going to return back what we call a feature set, and I'm passing the statistics query to it. So now this is where things get pretty interesting. Well, things can get fairly tedious. Fix something here. It's just code to write at this point. I'll cover a little bit of this. I did not define the stats div here. Let me grab that. So actually, I need to get a couple of these here. So let's go ahead. We're going to add those to the very top. These are just some div elements that exist on the page. So I'm going to add those to the top of my function here so they're available to me. I need to run format document on this or something because I've done something wrong. I think this should be like that. Yeah, I've done something wrong. I need to run format document on this thing. But okay, let's come back down to what we were doing here. So basically what I'm going to do is I have a div in here that's going to show up in a minute. That's going to have the statistic information that we're going to write out here. Right? I'm just going to write some information out here. So when you get a feature set back, that feature set is going to have an array of features, and these are essentially going to be graphics that you can pull information off of. And the way that we store fields is in a property called attributes. It's just a plain object that's kind of like attributes. In our case, what we defined as field names, attributes.max magnitude, attributes.average magnitude, and so forth. It's going to have that information for us. So we're just going to go ahead and loop over those field names, and we're going to just create some text that's going to show up over here. All right, so we've got that in here. I think I need another closing one. Yeah, there we go. Okay, so if I have results back, I'm going to go ahead and update this little information box that I'm showing over here. Now what I want to do, now I can go ahead and add this information here. So we're going to go ahead and Let's see here. How am I doing this now? Oh, there's my if. See, oh, let me do a format document here because I am losing my spot. Okay, somewhere along the line, VS Code got real weird on me there. Okay. So now what I want to do is I want to put this inside of something that I can click on, show it, and hide it when I don't care about seeing it, right? And we have a widget for something like that. We call it the expand widget. So I'm going to call it my info div expand is equal to a new. Oh, that's not what I want. That come from expand. And the expand widget is designed specifically to be a button on the page. You can click, it'll open up whatever element or div or picture you're showing in there, and then hide it when you don't care about seeing it. So it's going to have an expand icon class, and these are class names that maybe you can have defined in your own CSS. We have some already predefined, so I'm just going to call it Esri icon expand. I might not even need that. I don't know. I have to double check. And I want tooltips. I want a tooltip. So if a user hovers the mouse over that tooltip, it'll tell them what that button will do. So it's going to expand earthquake info. All right. I need to pass the view. The content is going to be the info div that we've defined above. That's this work that we're doing up here. We want that to be the content for this expand widget. And when it first starts the application, I want it to already be expanded. So expanded is going to be true. All right, awesome. Now what I want to do is I want to go ahead and add that to my view. So view.ui.add. We've done this a couple times already. So I'm going to add the info div expand, and we'll go ahead and put it in the top right. Now, because I haven't done it yet either, I'm going to create my legend now. I bring the legend in? I don't remember if I did. Let's see here. Okay, I got it. We can do this here. I haven't created the legend yet anywhere, so I didn't bring the class in. I know that. So I'll create legend expand. And you don't have to call them these. This makes it easier for me to know what I'm doing. When I first learned programming, development, I was always reading that and taught that you should be as descriptive with your names as possible, because when everything compiles down, who cares how long your names for things were? And of course, if you learn something like Java, you see what happens. I joke. I actually did not learn on Java, but I learned some stuff on Java. So the view for my expand again. Now the content is going to be a new legend, and just to make it simple, put the view in there. So I'm not going to create a separate instance and add it in. My legend isn't smart. In some cases, I don't really need to watch for any properties of the legend to change to do anything. I just kind of want it to display, so I don't need to have an instance that I can reference and do something with if I don't need it. So I don't want this expanded. All right, so expanded is false. That might be the default. I really forget. I think forget now, but we'll go ahead and make it false. I did it for the other expand up there, so might as well do it down here. So now I need to add my legend expand, and we're going to put this the top left. Yeah, because I've got my slider over here, so I can't really put it at the bottom, so I'll put it over here. I think that should be fine. So now if I save that, let's give it a second to compile. Hopefully no errors pop up. Hopefully no errors pop up with this. Let's go close that. We're using everything. Okay. Let's refresh this page. Oh, got something down here. Here. Cannot read RP filter of null. Not that. It's going to be this one. It's not liking that. Okay, so let's go ahead and let's do it off the layer. I was hoping to just get off the filter over here, but still on the layer. Wait for it to compile. Yeah, I don't see a reference to filter anywhere over here. All right, let's go and refresh our map. Play it. No, it's not updating. Okay, 1 second here. Okay, sorry. I had a typo going there. My bad. I got it all fixed now. Close that up. Let's refresh this page again. Okay, now this should work. So now as the slider changes from day to day, I should get information up here about what is happening with these earthquakes. There we go. So 10 earthquakes occurred between 526 and 527. The max magnitude for that day was 1.78. The average was 1.19. The minimum was 0.92. The average depth was 4.06. Now I could do max depth, min depth if I wanted to, standard deviation of depth. You know what? I don't need to do everything. I can just do kind of what I think average is pretty good. Getting the minimum, max, and average for magnitude is also really good. We had 18 earthquakes that day. Look at it, 60 earthquakes in one day. That is nuts, right? But again, look at the map. I could probably figure out, oh, there's quite a few earthquakes happening here, but I wouldn't have that number in my face. Just kind of like, wow, 60 earthquakes in a single day, which is just bonkers. 128 earthquakes in a day. That is just insane, right? So you can see you can create these really cool maps that do these really awesome visualizations, and you can do this kind of exploratory applications you can provide to your users to do these really cool things. You can embed this inside of one of your own applications, and you saw that we were able to query statistics and get that information directly from the data. You could feed this right into some chart library. Now you have like a full-on application, maybe showing different charts of information based on the data, which is really cool. We have some samples in the SDK that do some very similar things to that. It's just a very powerful way to work with your data. And you saw that TypeScript was very helpful for us throughout the creating this particular application, getting everything set up. The IntelliSense was a great tool. Gave me all kinds of hints on things to do. Let me know if I wasn't doing something correctly. It was just a whole lot of fun to work on. Hi everyone, thank you very much. I hope you enjoyed this workshop on building ArcGIS maps with TypeScript. I know it's an awful lot of information to take in. I kind of threw a bunch of stuff at you. We try to keep it simple by having a very basic application, just having a map, adding a layer, doing a little bit of showing data on the web page. And we had another demo that was a bit more involved. We brought in GeoJSON data. We did our visualizations for it. We went ahead and defined the pop-ups for it, used the time slider to do some querying, applied some effects to the data. It was all quite a bit of information there. We barely touched the surface of everything you could do. We didn't even get to touch 3D inside your web applications. Another awesome thing you can do with our API. So if you're interested in learning more, please check out developers.arcgis.com. That has not just our web technologies you can use, but all of our developer technologies available for your usage. But if you're specifically interested in the JavaScript API, which I hope you are, seeing as this is a TSConf workshop, please check out js.arcgis.com. That's all the documentation on our API, along with all the guide pages and more that I kind of showed you in terms of doing visualizations. We have more on working with the widgets, doing pop-ups, and a heck of a lot more information so you can build some really awesome apps. You can also find us on GitHub at github.com/Esri. We have a ton of different projects out there, a lot of resources available for you to use. So again, if you've watched this and you have any questions for me, please feel free to reach out. You can find me on social media, Twitter, Instagram, LinkedIn. On Twitter and Instagram, I am at odonet, ODOEnet. And you can always email me at my Esri email address, rubalcava@esri.com. Thank you.